and properties. And next also we have discussed about the cycloalkanes also, preparation and properties, particularly in the cycloalkanes, Bayer strain theory, Saxe-Maurer theory are discussed. Next, alkenes, what are the alkenes and preparation of alkenes. In that important is the Sergev rule, and also in the properties Markovnikov rule, anti-Markovnikov rule. We have discussed that one. Then the alkadienes, how the alkadienes are classified, what is the preparation, what are the important name reactions. That is a Diels-Alder reaction is there. That about the organic part. Now we will go to the third block. Third block consisting of the 3 units again. Atomic structure 1 and atomic structure 2. Next gas state is there. So before the starting of that one, the atomic structure 1, we will go to that one. And time permits me, we will start with the fourth group also, fourth block also. Why? Because compulsory each block is consisting of 10 marks question. That is the essay type question you have to must write. So already short types means there is a 50% chance means from the 2 blocks you can easy to getting of the 4 short bits. No problem. For the essay, we have to compulsory read any one of the lessons. In that we'll plan that one. By tomorrow we'll finish up all the whatever the portion is given. And the most of students are asking for the regarding of the books, that is the manual PDF. So friends, here you go and collect the books. Plenty of the books are there in the university. They're given the time from 11 to 4. They're issuing the books. Just you take your ID card and fee payment receipt. That's enough. When you go to the Jubilee number 45, road number 45, so directly go to the university, you will collect the manuals or your books. It's a very, very important. PDF means how to get enough from the device. You can't read properly. Whether it is a desktop or whatever the laptop or whatever the your mobile also. But better the manual is important one. So carrying of the books is important. So they are giving every day. But you are keeping in mind is fee receipt is that is the one you want and avoid ID card. If you are having that one, they will issue your manuals. Yes, now you are start with the block 1 atomic structure. So block 3, that is atomic structure. Friends, here atomic structure. Before starting the atomic structure, we are having a small idea regarding about matter. What do you mean by the matter? So many of not knowing of the matter. Matter means it is initial. Whether the whatever the living organism is sustaining here means because of the matter only. What is the matter? Matter is anything. It has a mass and also possess some. It is occupy the place. Matter means I'm using of this pen. Okay, this is having the some mass. It is also if you are placed somewhere, it is occupying some place. This is called as a matter. Anything in the universe which has having of the mass and also some place is occupied, that is called as a matter. So friends, it is a very clear about the matter. This matter, how the matter is made up of, how it is made up of, how duster is made up of, how myself is made up of, how your table is made up of, all this, all the things are, whatever the surroundings are us is called as a matter. So for the how the matter is made up of means so many studies are put forth. In that main study, important study is John Dalton's atomic theory. So John Dalton's study, what is the John Dalton is given as the matter is composed of smallest individual particle. The matter, whatever the matter, this is a pen or whatever the chalk or what duster, it is made up of with the smallest indivisible particles. He says that indivisible particles. Indivisible particles he called as, who John Dalton is called as atom. So friends, this is a very important one. The matter is made up of with the indivisible particles. So I will give the example of matter. Suppose you are having of the marble stones. That means you are playing with the marble stones now. You are filling the marble stone in a vessel. How you are? This is a vessel. Now filling with the stones, that is the marble stones, you are filling like that. These are the stones you are filling. Okay. See friends, I am writing off these particular stones like this. The matter is nothing but it is only. So this is a matter. Whatever it may be. In the universe, whatever it may, it has a mass, it occupies some space. This is called the matter. This matter is made up of how? Individual particle. These particles are filling like this, the marble stones. One marble stone in another marble, there is a small space is there. Okay. So due to that reason, suppose we are dipped the chalk. Chalk is a solid. When your chalk is dipped in the water, what happened? Some water molecule is observed. Where it is goes, sir? Actually, it is a solid structure. Where it goes means there is a gap between the one individual particle to the another individual particle, like that our human body also. So many cells and neurons are there. Okay, chalk also some small particles. The particle between the particles, there is a space is there. So the water molecule absorbed in that space. You are drinking the 4 to 5 liters of the water every day. That it will be present in between the cells and organs, or cells between the cells. There is a space is present. In that is present. So according to the John Dalton, this is nothing but these atoms are made up of like this. The individual particles are present. So the matter is made up of, right? This matter. What he says indivisible. This is a Greek word. Indivisible means it is called as an atom. Greek word. So you can't further divide it. But after that, so many scientists are tried again. So Dalton says as individual particle. I can divide it or not. So today up to now, that individual particle is again divided into so many number of small fragments. So many number, more than 100 now. Initially, individual particle is called as atom. Now the atom is divided into so many number of another minute particles. That in that particle, the main important particles are electron, proton, neutron. These three particles are called as fundamental particles. The fundamental particles are electron, proton, neutron. Electron, proton, neutron. So you know that the theory of the whatever the particles which are remaining, others are I only using of individual particle is divided into more than 100 now. Positron, muon, meson, pion. Okay, like that, so many number of particles are there. So according to John Dalton theory, it is a discarded because you say as an individual. Now I am divided into more than 100 particles. In that, main important particles are electron, proton, neutron. These are called as the fundamental particles. Remaining 97 or whatever the more than 97, you are calling as it is not a fundamental particle. Why it is called not a fundamental means when the atom is formed, only 3 particles will be stable. They are the stable particles are only electron, proton, neutron. But remaining other particles are just processing. That means formation of the atom. For the stability of the atom, they are only initiated. After that, there will be disappears the particle. Even though pion or muon, meson, whatever it. Okay, positron, these are all are the particles which are present in the atom. They are only for during the formation, the particle is existing. After the few seconds, it will be disappears. Only the stable particles are electron, proton, neutron. What is electron? Who discovered it? So electron is discovered by J.J. Thomson in 1897. I'm just brushing up these particular fundamentals. Why? Because atomic structure is required. The electron is discovered by J.J. Thomson in discharge tube. What is a electron means? He says that 1 unit negative charge. A particle is possessing 1 unit negative charge and negligible mass is called as electron. Please remember who discovered it is J.J. Thomson in 1897. This is electron is a charge is negative, 1 unit of negative charge, and the mass is almost all negligible. You can say put as a 0. This is called as an electron, is a fundamental particle. Now coming to the proton. Proton is nothing but it is discovered by the Rutherford. Okay, so the Rutherford is discovered. This particular name is proposed by Rutherford. What is a proton? Means a particle is possessing 1 unit of positive charge. 1 unit positive charge and mass is almost all equivalent to the hydrogen atom mass. Proton mass is how much? Almost all equivalent to the hydrogen atom mass, the proton mass. See, electron is a 1 unit negative charge. Mass is negligible. Proton is a 1 unit positive charge is there. Positive charge, but the mass is equal to the hydrogen atom mass. It is given as. So in the examination, suppose if electron, they ask the but one electron is discovered by J.J. Thomson. Okay, so in 1897, it is charge is the means you are using our charge is negative and mass is negligible. I'm using that word. So proton is the name is discovered by the Rutherford in 1898 after the 1 year only. The charge E means as a charge. Please remember this is called as a charge is a positive and mass is equivalent to the hydrogen atom mass. This is nothing but 1.66 into 10 to the power of minus. Okay, I'm writing clearly 1.623 into 10 to the power of minus 23 grams. It is the mass is negligible. I'm using of 9.11 into 10 to the power of minus 28 grams. If you want the clear picture. Okay, this is the mass. Now the remaining other one more particle is the fundamental particle neutron. See friends, here in this particular case in 1897-98, this is a discharge tube. That is the experiment is done by the cathode discharge tube. They are made like this. Their formation of this one is a positive charge and negative charge. But in this case, we are having of the one negative is over, one positive is over. Remaining, we don't have any other charges. But the atom is having some mass. That mass is present in the neutron. So neutron is discovered by Chadwick. Neutron is discovered by Chadwick in 1932. So after the so many 34 years after, it is nothing but in the bombardment of small nuclei. Beryllium is reacted with the or beryllium is bombarded, collided with the helium particle. The new element is discovered, carbon is discovered. At that time, the neutron is discovered by the Chadwick. Neutron is nothing but charge is no. Why? Because no charge. Why? Because already you are having the positive, negative. We are having the only two charges. No charge. But the mass is almost all equivalent to the proton mass. That means it is 1.625 into 10 to the power of minus 23 grams. Almost all equivalent to the proton mass is a neutron is there. So these are the fundamental particles which are present in the atom. Before the John Dalton, it's not an individual particle. But today you are divided into more than 100. In that 3 are existing in the atom, always existing in the atom, electron, proton, neutron. Okay. So friends, in the atomic number, we are writing if hydrogen representation of this is the atomic number, this is the mass number. So this atomic number indicate what? Number of electrons and number of protons present in the hydrogen. So hydrogen consisting of one electron is there, one proton is there. Coming to the neutron means we are applying of this one Z. X is nothing but any atom, hydrogen or helium, whatever the element is X. Z is called as atomic number. This is atomic number. It is called as atomic weight. So atomic number Z indicates what? Number of electrons as well as number of protons. But A minus Z, that means atomic weight minus atomic number indicates number of neutrons. N is small n, I am using of neutrons only. So please friends, here hydrogen atom is consisting of how many number of neutrons? How many number of neutrons? A minus Z means here 1 minus 1, it is a 0. So neutrons are 0 for particularly hydrogen atom. In the whole total periodic table, no neutrons is present in the atom is hydrogen. No neutron, single neutron is not present in the hydrogen, but remaining other elements, all elements is having of neutrons. So this is indicating of this particular figure, we are having of. So it is also equivalent. Why? Because one electron mass is 0, means 0. One proton is there, one proton is 1 unit. It is nothing but 1 unit means 1 hydrogen atom. 1 plus 1, that means a charge. 1 plus 0 is a atomic weight 1 we are getting off. Okay. So if you are taking off helium 2, atomic mass is the weight is a 4. 2 electrons are there, 2 electrons, 2 protons, and also number of neutrons are A minus Z means how much? It is 4 minus 2. It means 2 neutrons are there. 2 electrons mass 2 into 0, 0. 2 into 1. Each proton mass is 1 unit. So 2. Each neutron mass is 1 unit. It is 2. Total 4. So 4 to 4 is rectify, your weight is rectified. That's why these are the number of protons and neutrons which are present in an atom. We are considering like that. So this is about the small fundamentals which are present in this. On the basis of this one, so you are aware of that one, the fundamental particles are present in the atom, where they are located. For that purpose, you are studying about the atomic structure. That is nothing but the particles, whatever the particles, fundamental particles, where it is located, how they are rotating. What is the nature of that one? So for the regarding of that one, atomic structure, that means atomic models are put forth that you are to study in the atomic structures. So friends, the first atomic model, that means to identify where the electron, proton and neutron is present. For that purpose, atomic models are put forth. The first atomic model is J.J. Thomson atomic model. The first atomic model is J.J. Thomson atomic model. J.J. Thomson atomic model. What he says in the J.J. Thomson atomic model, it is put forth in the 1911. This atomic model is put forth in 1911. So in the 1911 means how many number of particles are invented? At that time, only electron ENOS and also proton ENOS. Neutron is not yet discovered in this year. So according to that, the electron, proton, where it is present. So J.J. Thomson, he says that atom is allosphere. Most of this one, this atom is present. Inside the atom, that is a positive, that is plus. Positive charge and negative charge is embedded, uniformly distributed, like this, uniformly distributed. It is present in that case, uniformly distributed. Okay, like this, they are present. But if you see, when a positive and negative charge are very close to each other, what happens? Attraction force is there. If the positive negative charges are there, means there is an attraction force is there. If the attraction force is present, means there is a attraction will be takes place, atom will collapse. But J.J. Thomson does not explain. This model is also called as watermelon model. He says as watermelon. Watermelon is a spherical shape. Atom is a spherical. Inside, whatever the red spongy material which is eatable, that material is called as a protons. Proton is a positive charge. And whatever the seeds are there, the seeds are nothing but the electrons. He explained example with the watermelon model. That's why J.J. Thomson atomic model also called as watermelon model, because of this particular proton and the electrons are inside the atom only. But according to our concept, when the positive and negative charge are very close each other, atom will collapse. So it does not expire. That's why it is discarded. J.J. Thomson atomic model is discarded. Next model is, that is nothing but yours, Rutherford atomic model. Rutherford is proposed the atomic model. Before that proposing of the atomic model, he conducted one experiment. That experiment is called as alpha ray scattering experiment. For your examination, this is a 10 marks question. What is alpha ray experiment? And also derive the atomic model of Rutherford. What the main concepts or main assumptions are given by the Rutherford. So please understand what is the alpha ray scattering experiment. Before we start the alpha ray scattering experiment, Rutherford alpha ray scattering experiment. Friends, here I'm using of the particularly experiment setup. I'm taking up the experiment setup. Just roughly, this is a lead block. It is called as lead block. That means the block, whatever the block is made up of with the lead. Why? Because lead is non-radioactive element. This does not emit any radiation. In this, I'm taking as a source. And place this is a source. This source is taken as a polonium. This polonium is atomic number is 84 in the periodic table and 218 is the mass number. Atomic weight is the 208. It automatically, that means the polonium is spontaneously emit the certain rays, and formation of a stable element, that is the lead 82, 214. Helium particle is emitted. Helium particle is called as alpha ray. Please remember here, helium particle is called as a alpha ray. So this particular lead block is used as this one. The source is the polonium, which emitting of What is emitting of alpha rays from the small hole? I'm keeping off one gold foil. This is called as gold plate. So Rutherford did the experiment. I'm using of this particular setup, Rutherford alpha ray scattering experiment setup. This is particularly gold plate, which is called. Before that one, after the gold plate, he kept as a screen. One screen is using out like this. I'm taking out, this is a screen. Okay. This screen, in this particular upper portion, this portion will be coated with the zinc sulfide. What is the use of the zinc sulfide here coated? This zinc sulfide means nothing but this is the coated with the zinc sulfide, ZnS. Zinc sulfide is coated. So this is the experiment setup. Lead block is taken. In that polonium radioactive element is taken. This polonium is naturally emit of alpha rays. This alpha rays, thin beam of very high velocity of alpha rays are emitting from this source. This source, this is a gold foil is kept. After the gold foil, one screen is present. This screen on the screen, it is coated with the zinc sulfide. What is the use of zinc sulfide? Means when a alpha rays is fallen on this screen, a flash of light will be produced. Alpha rays fall on the screen. What happened? A flash of light will be produced. By means of flash of light, you can count how many number of alpha particles are emitted by your source. The source is how many number of alpha particle is emitting. By means of the flash of source, you can count. So this is the experiment setup conducted by the Rutherford. By means of the Rutherford alpha ray scattering experiment, he conducted the experiment. By this experiment, he concluded that the observation made. What are the observations? These are the observations. I can write here only. Observations. By this experiment, Rutherford observed as the first one. Most of the alpha particles, whatever the source is emitting, most of the alpha particle means 99% of the alpha particles are passing through the gold plate. They are passing through the gold plate, and also you can counting the number of particles with a flash of light. Okay, so your screen we are getting. There's the first point he observed where the most of the alpha particles are passing through the gold plate. Second point, some of alpha rays are deflected very large angle. So some are through that one. They are deflecting like this. They are deflecting like this. They are deflecting like this. So I'm using of this one. They are deflecting. Okay. Some only. Already 99% is passing through this one gold plate. Only some are deviated. Some are deviated. Okay, he observed, right? Third point he observed as, suppose the source is emitting of 10,000 alpha particle. I am using of 10,000 alpha particle is emitted by the source. You are getting of 10,000 alpha particles are emitted. In this 10,000, a few particle means 10,000 out of 10,000, only one particle. This one particle, they hit it and come back to the back only. It is not passing or not deviated. It is reflected back along their back path. Only out of 10,000, only one particle, alpha ray, only one alpha ray is deviated. That means they are coming back path. By these three observations. By means of three observations, he concluded as, what is the conclusion? Rutherford conclusion as, see friends, this is a 10 marks question for your examination. Please draw the diagram, please, very important. Experiment setup and observation is, most of the alpha particle means nearly 90%, 99% of the alpha particles are passing through the gold plate. Some are deviated, and one out of 10,000, one is deviated along their back path only. That means they're coming back to the source. Again, it is into the source only. By means of three observation, he concluded as, atom is allosphere. It is allosphere. Most of the empty space is present. Atom is allosphere. Most of the empty space is present. That is the first point made by the Rutherford by this experiment. And the second point, in this second point, whatever the protons Why? Because he knows only electron and proton, these two particles. Where it is located, he is inventing by means of atomic model. So he observed by this experiment, he concluded the atom is allosphere. Most of the empty space is present. Due to that reason, the alpha particles empty space is there. That's why the alpha particles are not deviation. They are going outside. That means they are passing through the gold plate. 99% of the alpha particles are passing. But some second observation, what is there? Some are deviated like that. Some are deviating. Why the deviation occur means at the center, the positive charge means a protons and the mass of the atom is concentrated. That means second point, the protons as well as the mass of the atom is concentrated at the center. This center is called as nucleus. Nucleus is put forth by the Rutherford. At the center, atom center, that means atom is hollow sphere, most of the empty. Due to that reason, 99% of the alpha particles are passing through the gold plate. There is no deviation at all. But few are deviated. Why they are deviated means there is a center is the positive charge is there, and also mass of the atom is concentrated here. This positive charge and mass of the atom of this one concentrated center is called as a nucleus. Due to the positive charge, they are deviating. Why, sir? So alpha particle, what means? 2 units of positive charge. This is a 2 units of positive charge is there, and 4 units of mass is there. Alpha particle is nothing but 2 units of the positive charge and 4 units of the mass is there. 2 units of the positive charge, positive, what happened? It will be repels. Positive means it is repelled. Before that, there is no layer. It is a empty space is there. That's why they are passing. Only between their particles are present here. Some are deviated. Only some are deviated like this. Not all. Only few rays, alpha rays are deviated because at the center positive charge is there. Our alpha particle also carrying of 2 units of positive charge. That's why it is deviated. E concluded. Third point. 1 out of 10,000, they are coming back means at the center, one particle is going. What happened? It is a positive charge, it is positive charge. So what happened? It does not pass, does not deviate. They are coming their back path only. These are the conclusions made by the Rutherford. I hope you can follow this one. 3, by means of only one picture, you can follow that one. So by means of the observation, a conclusion also taken as 3 steps only. Atom is allosphere, most of the empty space is there. Due to that reason, 99% of all alpha particles are passing through that one. And some are deviated because of the alpha particle is 2 units of positive charge is there. There is a atom is having of the positive charge and mass is concentrated at the center. Due to that reason, the positive charge repulsion will be takes place. That's why the alpha rays are deviated. 1 out of 10,000. One particle, why? Because it's at the center, this particle is passing. So it is deviated along their back path only. So they are deviated along their back path. By means of this is called as a total called as Rutherford alpha ray scattering experiment. By means of this Rutherford alpha ray scattering experiment, he made as a Rutherford atomic model. So we will go to the Rutherford atomic model. Similar points we can repeat it again in the model by means of the experiment. So what is the Rutherford atomic model means? Rutherford atomic model. Please remember the points. I'm using the first point. Atom is hollow sphere. Atom is hollow sphere, and most of the empty space is present. Most empty is there, completely empty. A small portion. That means at the center, this very small portion, positive charge and mass of the atom is concentrated at the center. That center is called as nucleus. Atom is hollow sphere, most of the empty space is there, and positive charge means it is a proton. Positive charge means it is a proton. Proton and mass of the atom is concentrated at the center. The center is called as a nucleus. Third point. From the center, the electron means negative charge. Okay, negative charge. It is an electron is revolving around the nucleus. That means there is a positive charge. Here positive charge is there at the center. Here electron is there. Electron is revolving like this. from the nucleus. The electron is, it is a far distance from the nucleus. Electron is revolving around the nucleus with very high velocity. He made as in the atomic model. So already I told that why the atomic models are put forth, where the fundamental particles are located. For that purpose only, in the 1911, before that, in the we are using of the J.J. Thomson atomic model, only electron proton is discovered, so that he decided as a it is nothing but watermelon model. But positive negative charges are very close each other, it will be collapse. Atom will collapse, but atoms never collapse. Atoms are stable. So that's why the atomic model is discarded. Next, we will go to the Rutherford model. By means of the alpha ray scattering experiment, he concluded that atom is allosphere, most of the empty space is present, and positive charge and mass is concentrated at center is called as a nucleus. Around the nucleus, the electron is revolving. Around the nucleus, the electron is revolving with very high velocity. Next point, what he says is that the revolving electron, just like our planetary system, that's why this Rutherford atomic model also called as planetary model. Planetary atomic model. Planetary model means why? Sun is at the center. Remaining other planets are revolving around the sun. Here sun means nucleus. Nucleus is at the center. Electron is revolving around the nucleus. Electron is revolving around the nucleus. Our earth is rotating around the sun. Our earth is the third point. Okay. So whatever that one, your order is there. Okay. So you are having Venus, Mars, but is the your whatever the planetary system is there, just like the electron also revolving around the nucleus. This electron, the revolving electron for around the nucleus is having of the two forces. The revolving electron is having of the two forces. One is called as centripetal force. Centripetal force. Another is called as the centrifugal force. The second kind is centrifugal. Two forces are acting on this particular revolving electron. So friends, I clearly mentioned the electron is far from the nucleus. This electron is revolving. This revolving electron is having of the two forces, centripetal force, centripetal means this is attracted towards the center, is called as a centripetal force. Centrifugal means they are attracted outside the revolving path, not center. Is repelling from this particular electron. Revolving path is here. This is the revolving path. From this, they are repelling. These two forces are equal. The two forces are equal but opposite direction. One is inside the attraction will be the express. Another is outward direction. Outside attraction is there. Outside, outward attraction, inward attraction, both are unequal. Forces are equal, so that the electron is revolving in their path only. So for this purpose, I will give the small example. You see your ad in the TVs or whatever that one, Fevicol ad. One person is sitting on the chair, is faced with the Fevicol. Here you are getting of elephant is there, and one more elephant is there. Where elephant means more energetic, they can laugh. So if you are drawing of this one, I can't move it this side or this side. Why? Because I am faced with the Fevicol bond, that is called as that much of strong. Here this particular electron is how much force is attraction. Same force is attraction outward direction, so that it will be stay there only. Fevicol like that, it is stick. It will be revolving in this orbit only. That is given by the Rutherford atomic model. Please remember the 4 points. Atom is allosphere and most of the empty space is present. And atoms positive charge, that means proton, and atom mass, total mass is concentrated at the center. The center is called as a nucleus. Around the nucleus with a far distance, electron is revolves. This revolving electron is having of the two forces. One is the centripetal force, another is the centrifugal force. Centripetal means it is directed inward direction. The force is acting towards the nucleus. Centrifugal means it is away from the revolving path. Away from. But these two forces are equal but opposite direction, so that the electron is revolving in that path only. Given as. Is any defects are there in this experiment, in this atomic model? You know that one. Suppose all of you come to the ground. I'll say, I draw one circle. You stand on the circle only. I given the cautions. The condition is I draw the circle in the ground. You stand on the circle. I start the whistle. Please run on the circle. You are running very fast. Electron also, just like you are the electron now. You are running very fast around the circle. Whatever the path I given, I draw the path. After the few seconds, after the few minutes, sometimes, what happens to you? Sir, bolte, chakkar aa raha hai saab. Chakkar aate na? Why you are getting off giddiness? Because you are losing your energy. Think about this one, this experiment. Okay, why you are started with the circular path? You are moving very fast. After the few seconds, some person, after the few minutes, I don't think about. After the few seconds only, or 10 to 15 rounds only, you may getting off the giddiness. Sir, chakkar aa raha sir. Chakkar aaya to main collect karke bech दूं. Don't bother. Sugar is very precious for me. You are getting off giddiness. That means you are filling up the sugar. That means chakkar aa raha hai bolke. Okay. So this is nothing but you are losing of energy. Immediately after that, no. You can run. I will say the cautious. You are running. Why? Because my cautious. You are following my whatever the voice. After the few seconds, what happened? You can fall down. Definitely you can fall down. If electron is revolving around oppositely charged particle, this is a positive, here the negative. You are revolving around that one. What happened to this electron? It loses energy. If you are losing the energy, this is a positive charge. Oppositely, here the electron is there. You are revolving. Ultimately fall into the nucleus. But Rutherford does not explain. According to the electromagnetic spectra, any oppositely charged particle is revolving around the nucleus. It ultimately loses its energy. If the losing of energy means it comes closer and closer in spiral path and fall into the nucleus. So the fall into the nucleus means atom will collapse. But what I say, atoms are stable, does not collapse anywhere. After 1,000 years or 1,00,000 years, atoms are stable only. They do not collapse. He does not explain. This is the first defect of the Rutherford model. I hope you can understand this particular concept. Given the example of you are going to the running around the circular path in the ground. This is nothing but ion only. The electron is. Even the two forces are there. You can say, I'm having the two forces, but you are running this one around the nucleus. Definitely, you can lose your energy. Okay. Into the nucleus, the atom will collapse. It does not explain. This is a very first defect of the Rutherford atomic model. Due to the defect, and the atom does not explain the stability also. The Rutherford atomic model also says that the first defect and stability is not explained. How it is?
Please mute your mics.
Okay, all of you friends, mute your devices. Don't disturb in between my class, particularly. Don't disturb me. Please be serious. These are very, very important questions in the examination point of view. You are already aware of from the 8th class onwards, this particular atomic structure. I hope in this 8th or 9th class it is there. But it is elaborately you are saying up in this particular degree level, you have to write every point. Atomic structure, the alpha ray scattering experiment setup, and what they are observations, what they concluded. From the conclusions, he made one atomic model that is called as a planetary model. He made some assumptions. These are the assumptions. In these assumptions, we are having of some defects are there. The defect is stability is not explained. How their atom is stable. So without stable, you can't say. And the next, if it is a spiral path, that means if according to the electromagnetic spectra, the oppositely charged ion is revolving, means that definitely loses energy. It is also not explained. So this will be two defects are there. If the defects are there, means one more scientist will be born. That is your Bohr's atomic model. For that explaining of these defects present in the Rutherford atomic model, Bohr is explaining one more model that is called as Bohr's atomic model. Before the starting of the Bohr's atomic model, I will use up the small, why? Because in your the characteristics are there and also spectra is there in between the Before that, spectra and characteristics, you can discuss about the Bohr's atomic model. Okay, so we'll go to next immediately Bohr's atomic model. Otherwise, next go to the remaining other topics. You can't deviate that one. Okay, so these are the two defects are explained by the stability as well as the collapsing, the energy losing, explained by the Bohr's atomic model. We can explain in this Bohr's atomic model. What are the important assumptions of the Bohr's atomic model? Next is Bohr's atomic model. Now friends, Bohr is adapted 50%, more than 50% basic concept of the Rutherford only. What are the basic concepts? Atom is allosphere, most of the empty space is present. The positive charge and the mass of the atom is concentrated at the center. The center is called as a nucleus. Around the nucleus, electron is revolving. This is a basic concept of Rutherford that is adapted by the Bohr's atomic model. That means the first point is Rutherford atomic model only. Atom is allosphere. Atom is allosphere and most of the empty space is there. Empty space. I'm just writing the keywords only. I'm writing the keywords only here. Atom is allosphere, empty space is present, and positive charge and mass concentrated at the center. This center is called as nucleus. This is a Rutherford only. Third, around the nucleus, the electron is revolving. But in the third point, Bohr says that the stability also he explained. And also does not lose its energy also he explained. So at the third point, what he says, so at the center, you are having of the positive charge and mass is there. So this is the mass. Around the center, electron is revolving in circular path. This is a circular path. This is a circular path. This is a circular path. He made as the circular path the concept. These circular paths are called as orbit. That is the third point he says as. So the extra point apart from the Rutherford, these two are the basic concept. He retained same points. But the third point, electron is revolve around the nucleus in a closed circular path. These closed circular paths are called as orbit, and also they named as this closed circular path. First circular path is called as a K shell, K, L shell, M shell, N shell. See friends, this is about the KLMN. KLMN shells are represented. Orbit's name. That means N is equal to 1. This is the first orbit, second orbit, third orbit, fourth orbit. First orbit is called as a K shell. Second orbit is called as a L shell. Third orbit is called as a M shell. Fourth orbit is called as a N shell. He designated the letters very particularly. And also he explained the stability of the atom. Each orbit is associated with a definite amount of energy. That is a quanta of energy. First orbit is having of quanta h nu. Is a Planck's constant, h is a Planck's constant. So the energy h nu is the here, nu is the frequency, h is the Planck's constant. So Planck's constant, what is the Planck constant in our examination? Without this, you can't write the exam. That means it is a 6.627 into 10 to the power minus 34 joule second. Joule second. Or sometimes it is 6.627 into 10 to the power minus 27 egg second. Whatever it may be, both are the similar only. This is a Planck's constant in the examination multiple choice question. 6.627 into 10 to the power minus 34 joules or 6.627 into 10 to the power minus 27 ergs. Why? Because according to the Planck's equation, that is a quantum chemistry, this each orbit is associated with a fixed amount of energy that is called as one quanta. H means it is a quanta. Quanta of energy is present. One quanta, 2 quanta, 3 quanta, 4 quanta. These are the energies associated. That means, suppose I am here. How much energy I required means that much of your food is taking for the sustain of your life, for daily life. That means you are sustaining purpose. You are taking of the food. For the food, you are getting of energy. Here also electron is revolving for each orbit. Each orbit is how much of energy is required. That of energy is associated by means of Planck's equation. That is given as 1 quanta of energy is present in the first orbit. That is a K shell. 2 quanta of energy is called as a second shell. 3 quanta of energy is called as a M shell. 4 quanta is called as, this is called as a quantization of energy. 1, 2, 3, 4, 5 quanta of energy in this quantization of energy is present for each orbit is given as. That's why atom is stable. First defect is clarified. Next, coming to the fourth defect, fourth point of this particular Bohr's atomic model. Now, every orbit is having of its own energy. They are revolving in that electron. Suppose a fixed, that means particular orbit of electron neither gains the energy nor loses its energy. This particular, I am fixing of the third orbit. This electron neither loses energy nor gain energy. They can't give the energy. Such electron revolving in such particular third orbit only. That orbits are called as stationary orbits. Given an extra point only. Are you following this? Stationary means what? It is that particular orbit neither gains the energy nor loses its energy. Suppose you are giving the extra. आप लोग फिर रहा है, आप लोगों का बैठ रहा है क्लास पे. You want the extra energy means आपका मतलब क्या कर रहे? आप सुबह बैठ रहे ना, टिफिन का ला के आते, नहीं तो कुछ items to getting of the energy purpose, the biscuits खाओ बोल के. Here the particular electron is revolving in, that means this particular electron, third orbit, it doesn't lose its energy, it does not take the energy. That means that particular electron is revolved in that particular third orbit only. Such orbits are called as stationary orbits. Suppose, fifth point given as, suppose the electron gains the energy. What happened? Already it is having its own energies are there. मेरा कितना energy हो ना उतना खा लिया. अब लोग extra दे रहे तो क्या कर? I can exert it. That means the electron is gaining the energy, means they can jump into the higher state. If the electron is loses energy, means it jump into the lower state. But the difference in energy, that means delta is called as the difference in energy. What is the difference in energy? Higher energy, E2 minus E1, lower energy. It must be a 1 quanta. H nu only. The fifth point is very, very important point. If suppose fourth point is what is given as any orbit does not gain the energy, does not lose energy. Such orbits are called as stationary orbit. Suppose a peculiar person, a peculiar case. If you are forcefully heating the atom, forcefully heating means some exact nothing but the particular electron gains the energy. If the gaining of electron in such an orbit, it will be jumped to the higher orbits. If suppose you are losing the electron, it jump to the lower orbit. But difference in energy from the higher orbit to lower orbit, the difference in energy 1 quanta only. That is nothing but E2 minus E1 is called H nu only. That is given as a fifth point. And coming to the sixth point, electrons is revolving in circular paths. Circular path is having of angular momentum. Angular momentum is MVR. This is called as angular momentum. So revolving electrons are present in this particular circular path, and these are orbits. This angular electron is having of angular momentum. Angular momentum is must be equal to the integral multiple of, integral means integer n, h by 2 pi. This is a product of nh by 2 pi. What is the product? The angular momentum is equal to the nh by 2 pi is given by the Bohr's. How it is, sir? Don't ask the question. Bohr also does not explain. Why the angular momentum is nh by 2 pi? Why not another? He does not explain. But electron is having of angular momentum. Why? Because it is rotating around the nucleus. Due to the rotation of the nucleus, angular momentum is there. That angular momentum is integral means integer 1 to 3, 1 to 3, whatever the orbit. H is the Planck's constant. Planck constant is there, the constant value by 2 pi. Pi value is 3.14. It is a constant. So everything will be constant will coming. What constant? We don't know. Why it is taken as, you don't know. It is given as angular momentum is equal to the nh by 2 pi. By means of 5 assumptions, he made one equation that is called as Bohr's equation. So Bohr equation, what is the Bohr equation? What is given as the equation is, that is, he calculated the radius of each orbit. R is equal to n square h square 4 pi square z e square m. See friends, n means integer 1, 2, 3. H means Planck's constant. It is a constant. Pi is the constant 3.14. Z means atomic number of atom. Z is nothing but atomic number of an atom. E means electron charge or electron mass. That is the electron E square, and number of electrons, mass of the electron. R is the mass of the electron. By means of this one, you can calculate the radius. This means this is the radius. The distance between the orbit to the nucleus is called as a radius. Okay, like the second radius, like the third radius, you can calculate by means of this equation. But the 5.6 points are very important in the examination point of view. You have to write in the Bohr's atomic model. What are the assumptions? Means you have to write the 6 points. Then he calculated that is a radius, that is called as a RA. Bohr's radius is there. The Bohr's radius RA is equal to 0.529 n square angstroms. This is a Bohr's radius. That means the first orbit or second orbit, but you don't want that one. This is given as the by means of the calculator. Why? Because these are all are constant values. If suppose hydrogen is atomic number 1, then it is called 1. Electrons, what is the electron is there? What is the mass is the electron? From this you can get which orbit is present. There is a number. N is a number of orbit. First orbit or second orbit or third orbit. For that you can calculate the radius of the particular hydrogen atom. That is given by the Bohr's atomic model. So I hope this Bohr's atomic model also for the 10 marks question. So alpha scattering experiment, Rutherford atomic model, Bohr's atomic model. Now we'll go to the next point. That is nothing but spectra. What do you mean by the spectra? Means simply I will explain. The spectra means it is a prism. When a white light, I'm using of sunlight, and sunlight is fallen on a prism, what happens if it is split into several number of component lines? You can keep on the screen. This is a screen. You will getting off VCR. Okay, that means the white light is composed of 7 colors. VCR color is obtained. This phenomenon is called as spectrum. Spectrum means what? When a ray is fallen on a prism, is split into number of component lines. The component lines are well defined distinct lines. You can calculate the wavelength as well as the frequency. When you can obtain on the screen, you can call it is called as this phenomenon is called as a spectrum. Okay, this is a spectrum. You are observed. This is a dispersed spectrum. You are getting of violet, indigo, blue, green, yellow, orange, red. This is called as a 7 colors. So white light is nothing but 7 colors mixture. Rainbow colors. White is not a color. Please remember, it is not a color. It is a 7 colors combination is there. This spectrum we are using of hydrogen spectra. So what is hydrogen spectra? In the examination they will ask what is hydrogen spectra. Explain hydrogen spectra with Bohr's atomic model. The question is like that. Already you know that Bohr's atomic model. What is hydrogen spectra? First of all, you see the hydrogen spectra. Hydrogen spectrum. Okay. So first hydrogen spectrum, you'll see that what is hydrogen spectrum. From that, so the hydrogen spectrum, you see, I'm taking off the experiment setup. This is the discharge tube. It is discharge tube means it is a vacuum. Taken as a discharge tube. I am filling with this in the hydrogen gas. Only hydrogen gas is please fill this one. From this a ray is emitting. That means a gas is coming from this is color red color ray. Red color ray is emitting. Okay. This red color A is fallen on your prism. So So this red color will be split into number of component lines like this, which are keeping on your screen. This is called as a hydrogen spectrum. Simply you say that what is hydrogen spectrum is a gas is filled within the discharge tube. So you are connected the battery, 10,000 battery, 10,000 volts of the battery is connected. This volts of the battery. So due to of the heating of this hydrogen gas, it is emitting of red color gas. The red color ray is emitting. This red color will be falling on the prism. It is split into several number of distinct component lines. Well-defined distinct lines are present. Why? Because hydrogen spectra is a line spectra. It is a not a band spectra. It is a line spectra. Line means each line is you can easily calculate the wavelength. That is called as a line length. In between the one line to the another, there is a distinct lines are there. That's why it is called as a well-defined distinct lines. So you're getting off this spectra. This is called as a hydrogen spectra. When the scientists are, these lines are present on the screen. The scientists are classified, these lines are into 5 series. The hydrogen spectra, the lines are classified into 5 series. First series is called as a Lyman series. Second series called as Balmer series. Third series, Lyman Balmer. Next series is Fortune series. Next series is called as Bracket series. Next series is called as Fund series, Phi Fund or Fund series. Please remember this is a very, very important one. Hydrogen spectra. So when hydrogen spectra means your gas is filled in the discharge tube, heated means electricity passed to 10,000 volts. It will be heated. You are getting off red color ray. That means a gas, red color gas is coming out. This color ray is fallen on a prism. It is split into several number of component lines. These component lines are classified into 5 series: Lyman series, Balmer series, Fortune series, Bracket series, Fund series. Okay, hydrogen spectra is consisting of 5 series. The names are these are all our scientist names only. First series, that means not a first in the hydrogen spectra, the first Balmer is discovered Balmer series. First discovered the Balmer series in the visible region. Which region? Visible region. Region is very, very important your examination point of view. In the hydrogen spectra, Balmer first discovered in 1898. That is Balmer series in the why? Because visible we can see our naked eye. Next in 1904, Lyman is discovered. Lyman series in the ultraviolet region. In the UV region, it is discovered. The region also very important. Next, Fortune in 1908. Fortune is discovered. This Fortune series in infrared region. And Bracket is discovered in 1922. It is also in the infrared region. Fund in 1924, he also discovered in infrared region only. That means, please remember, Lyman series is present in the ultraviolet region. Balmer series is present in the visible region. Fortune, Bracket, Phi Fund series are present in the IR region only. That you have to remember. These are 5 points very important in the hydrogen spectra. You are clarified that the getting of the idea regarding of the spectrum is it is a split into several number of component lines. These lines are present as a Lyman, Balmer, Fortune, Bracket, Fund series. This is about the hydrogen spectra broadly. Okay. Now this hydrogen spectra is explained by the Bohr's atomic model. How the Bohr is explained this hydrogen spectra? Why? Because hydrogen is consisting of only single electron. Atomic number is 1. 1 electron is there. Sir, 1 electron, how you will getting of number of component lines? That's a big question. 1 electron means only 1 line will be obtained by the getting. But we are taking on the discharge tube, gas is taking, not a single atom. If you are not taking of single atom means gas is consisting of large number of atoms are there. Large number of atoms means each atom is having of 1 electron. Each atom is having a 1 electron means when you are heated, it will be absorb different amount of energies. Due to the absorbing of different amount of energies, what happened? If you are taking off extra energy, it will be excited. It getting to the higher state. Why? Because you are giving extra energy. Whatever the energy is there, it is associated, it is having, but you are heating. Due to the heating, what happened? The hydrogen is gaining of energy. Due to the gaining of energy, the electrons are excited state. They are jump into the higher state. Ultimately, what happened? If jump into higher state, at higher state, what happened? That particular electron is unstable. How it is, sir? Suppose I took the meal. Then you call you, sir, मेरे कने extra buffet hai. That means you are having of what to some biryani. Already you took the meal. So extra biryani, you are excited. You are taken that one. You are, by the temptation, you took that one biryani also. After the biryani, what do you learn? You can uncomfortness. Why? Because extra food is present in your stomach. Uncomfortness. You can like that. So here the electron is jumped to the higher state. In that higher state, the electron is not stable. It loses its energy. Losing of energy, one is losing when, where from that particular electron is there, where it is jumped, how much of energy it loses. If the electron from any higher state to, it loses into energy and fall on the first orbit, that series is called as a Lyman series. Okay, I will explain with the photograph that particularly whatever the Bohr's atomic model, explanation of the Bohr's atomic model, the hydrogen spectra. Explanation of hydrogen spectra with Bohr's atomic model. Bohr's atomic model. Okay, friends, this is about the heading of your question. It is also a 10 marks question. How it is explained? I will see that one. This is, you know that one. This is the nucleus of atom. I'm taking off circle only. The first orbit. This is the first orbit. N is equal to 1. It is the second orbit. It is 2. It is third orbit. 3. Fourth orbit. 5. 6. Like that. Number of orbits are there. Like that you are having off. Electron is here. Why? Because hydrogen atom is having of only single electron that is present in the ground state only. I am forced to eating this particular electron. What happened? This electron is gains the some energy. It jump into the higher states. At higher state, the electron is unstable. आप लोग extra खा लिया. So you can't digest that part properly. So uneasiness is there. This electron is gaining of some extra energy. So getting to the higher state. Depending on absorption of electron, maybe jump into the second or third or fourth or fifth or sixth or seventh or infinity. At infinity to lower orbits, the electron is present. Those are all unstable. What happened? If the infinity to electron, this is the infinity, jump into the first state. I am coming to the first state. Or from the lower orbit to jump into this one, from this one, from this one, from this one, or from the second orbit to first orbit. This series is called as Lyman series. And to find out this one, from any higher orbit, the electron is unstable. They jump into the first orbit. Whatever the lines are formed, those lines are called as Lyman series. They are present in the ultraviolet region. Why it is happened, ma? Each hydrogen atom is only single electron is there. You are eating. Due to the eating, that particular atom gains the energy. But we are taking sample of gas. Sample of gas is consisting of number of atoms of hydrogen. Each is one only. But depending on the number of atoms, the energy absorbed will be take space. It's not common for all electrons. Suppose the electron is gaining of 4 quanta of energy, it jump into the fifth orbit. Already 1 quanta is there. 4 quanta of energy absorbed means 4 plus 1 is it jump into the fifth orbit. Suppose 1 electron is gain the 7 quanta of energy. Already 1 quanta it is own. So 8 quanta it is jump into the 8th orbit. In any higher orbit, the electrons are unstable. So if the particular electron in the higher orbit, they jump to the second orbit only. Why they are jump to the second orbit, sir? They loses that much of energy. Actually, its own 1 quanta is there. It absorbed number of quanta of energy, but it loses only it remains the 2 quanta of energy, jump to the second orbit. So from higher orbit to second orbit, like that. I'm using this series is called as Balmer series, where the second orbit only they are jumping from higher orbit. It will be in the visible region. It is visible region. From like that, similar way, from higher orbit to the third orbit, only third orbit, from higher orbit to third orbit. This is called as Fortune series. From higher orbit to the fourth orbit, this is called as Bracket series. Okay, from higher orbit to the fifth series, that is we are getting off fifth one only. This is called as P fund series. It is in IR region. It is also in IR region. It is also in IR region. This hydrogen spectra is explained with the Bohr's atomic model. This is atomic model of Bohr's. Because of energy states, he explained this one. Why? Because hydrogen atom, the sample of hydrogen atom consists of not a single electron, single atom. Number of atoms are there. Even though each atom is only single electron, they are gaining of different amount of energy. They are also losing of different amount of energy. Due to this reason, if any higher orbit to electron is jumped to the first orbit, the lines are Lyman. If any higher orbit to the second orbit they are jumping, those are called as a Balmer. In any higher orbit to the third orbit, it jumps, that is called as a Fortune. In the fourth orbit is called as a Bracket. It is a fifth orbit, it jumps means it is called as a Phi fund series. This explains the hydrogen spectra beautifully with the help of this one. So energy diagram also like this. This is the energy diagram. This is particularly you can say in any higher orbits like that. N is equal. These are the N is equal infinity. Like that you are having a first energy, second, third, fourth, fifth, like that infinity is there. That is jumped to the from higher orbit to first orbit. This is the first orbit. I am using C. Clearly I am mentioning the structure. This is called as a Lyman series. The energy is minus 37 kilocalories. This energy, ground state energy level. This ground state energy level is 13.7 kilocalories of energy. From higher orbit to the second orbit. This is the second. They fallen like this. It is called as a Balmer. Okay. From any higher orbit to the third orbit. Like this. It is called as a Fortune. From any higher orbit to the fourth. It is called as a Bracket. From any other orbit, this is called as a Phi fund. This is the energy diagram which is made with the help of this one. So it is proved with the energy diagram also by means of the Bohr's atomic model. So this is about the hydrogen spectra explanation of Bohr's atomic model. It is also very, very important to you. Okay. So these are the atomic models which is over. Rutherford atomic model, Bohr's atomic model, hydrogen spectra, and explanation of hydrogen spectra with Bohr's atomic model. These are all our essay type questions. Now coming to the one more essay type question is there. That is quantum numbers. So what is quantum numbers, sir? Why it is important to study? That is important for us. Why the quantum numbers are important to study means already you know that you are having of the fundamental particles are there. In that fundamental particles, the proton and the neutron and the mass. Proton, neutron and mass. These three are present at the center in the nucleus. That's why this nucleus is called as nucleon. Nucleon means protons, neutrons and mass of the atom is concentrated in the nucleon. And electron is revolving around the nucleus. By means of quantum numbers, you can identify an electron in an atom, where it is present, how it is present, how it is rotating, in which direction the electron is rotated. By means of quantum numbers, you can identify. So that is the importance of the quantum numbers. So the quantum, what is the importance of the quantum number? To identify an electron, identify the electron in an atom, how it is present. That will be measured, or you can identify by means of quantum numbers. You are having of the 4 quantum numbers. These are must be present in the order only. First quantum number is called as principal quantum number, and second quantum number is called as azimuthal quantum number, And third is called as a magnetic quantum number. And fourth is spin quantum number. So friends, we are having of the 4 quantum numbers are there, that must be in order only. So many students, every time I'm explaining like that, but the students are not coming to the classes, they are writing out. First quantum numbers are, they know that in the school level, quantum numbers, they know the 4 quantum numbers, but they're not writing in the order. First they are writing the spin quantum number, next principal quantum number, next magnetic, next azimuthal. This is not the way. Why? Because you can see how it is in order. Without, once you know, does not know the principal number, quantum number, there is no azimuthal. If does not know the azimuthal number, there is no magnetic number. It is a sequence is there. Now we say let us be finishing of the quantum numbers within a few minutes. What is a principal quantum number? It is a designated letter small n. Already you know that r bit. R bit is nothing but small n. N values are integer 1, 2, 3, 4, not 0. If 0 means what happened? N is equal to 0 means atom will collapse. That is in the present in the nucleus. But atom always stable. Always stable. Atom do not collapse anywhere, anytime. That's why n is an integer. N values are 1, 2, 3, 4. The principal quantum number is proposed by the Bohr. Just now you are already used. This is proposed by Bohr only. It is represented a letter n. These are also designated shells are K shell, L shell, M shell, N shell. These are the orbits or shells. K orbit, L orbit, M orbit. See friends, it is a capital letters only. But the principal quantum number, this is a small n. Here also n is there. This is a capital N. It is a orbit. It is a principal quantum number. Okay. So what is the principal quantum number means? See, I'm using of this particularly. This is the nucleus. That means here the protons, neutrons and mass all is present in this nucleus only. Around the nucleus, we are having of the orbits are there, like this orbits are the present. Those are called as a K, L, M, N shells, or N is equal to 1, 2, 3, 4 like that. Principal quantum number I am explaining. Okay. In this principal quantum, it is proposed by the Bohr. This is a designated. These are this one, and also each orbit, every orbit, how many number of maximum electrons can accommodate, also explained by the principal quantum number. That is different. That means it is explained with the help of this equation. The maximum number of electrons can accommodated by the each orbit. The maximum number of electrons can be accommodated by the each orbit is 2n square. 2n square means, sorry, you can say n is equal to 1 means it is the first orbit. First orbit means you can call as it is a K shell. K shell, how many number of electrons can accommodate? 2 into 1 square means 2 electrons. The first K shell can accommodate only maximum is 2 electrons. This is the first shell. The K shell, first orbit can accommodate maximum is only 2 electrons. Coming to the n is equal to, it is a second orbit. It is nothing but M shell. So 2 into 2 square means 4 into 8 electrons. Second orbit can accommodate maximum is 8 electrons. It is explained by the principal quantum number. Now third orbit, n is equal to 3. That is nothing but third orbit. This shell is called as, sorry, L, M shell this is. So 2 into 3 square means 18 electrons can accommodate by the third orbit. 18 electrons are present in the third orbit. Like that, n is equal to 4. This is the fourth orbit. Fourth orbit means n shell. 2 into 4 square means that is the 32 electrons can accommodated by the fourth orbit. This is explained by the principal quantum number. So the principal quantum number is explained by each orbit is how many number of maximum electrons. Only 2 electrons can accommodate. Sir, we are having the 12 electrons, sir. First orbit can accommodate only 2. Remaining 10 will be goes to the next floor. Next floor means second orbit. Second orbit can accommodate 8. 8 plus 2, 10 is over. Remaining still we are having the 2. You will go to the third orbit. Third is the third floor. Why? Because third can accommodate 18 electrons. These are the maximum number of electrons accommodated by the each orbit is 2, 8, 18, 32. That's why this principle is given as, equation is given as the maximum number of electrons can accommodated by the each orbit is 2n square. By means of this one, principal quantum number is explained by the Bohr. What is the significance of principal quantum number? If you see this principle, what is the significance? Main important significance is, see, the electron is present in the last orbit. Suppose you can know the size. That is what is the radius, sir? Size is, you know, by means of principal quantum number. If the size knows means what is the energy, sir? Fourth orbit, 4 quanta of energy. Suppose second orbit is there, 2 quanta of energy. That means the significance of principal quantum number, size and energy. The important of the size and energy will be explained by the principal quantum number. Now coming to the azimuthal quantum number. Azimuthal quantum number is proposed by the Sommerfeld. Sommerfeld is proposed. This is a designated letter small l. Small l. Small l is the azimuthal quantum number. Okay. So the values are minus L2 plus L. Sorry, you can not using this one. Sorry. Azimuthal quantum number values are 0 to n minus 1. After this only you are getting minus L. Okay. The azimuthal quantum number L values are 0 to n minus 1. Sir, what that means? Suppose if we see the example, n is equal to 1 means first orbit. In the first orbit, what is the L value? 1 minus 1 means 0. 0 is the 0 to n minus 0. If 0, L is equal to 1. N is equal to 2. N is equal to means second orbit. 1 is compulsory, 0 is there. Next is 2. 2 minus 1 means 1. So L values are 0, 1. If n is equal to 3 means L is equal to 0, 1, 2 is there. N is equal to 4. L is equal to 0, 1, 2, 3. What that means it is nothing but n is 1, 2, 3, 4 is called as a main shell. Main shell means KLMN. In that main shell, subshells are how many present? In the first orbit, subshells are only 1. That subshell is called as s orbital. If L is equal to 0, value is nothing but s orbital value. N is equal to, that means second shell, second main shell, that is nothing but L shell. In that L shell, how many subshells are there? 2 subshells are there. One is 0, that means s orbital. Another is L is equal to 1, means it is a p orbital. So friends, here you have to use the words, that is the values are L is equal to 0 means it is called as a s orbital. L is equal to 1 means it is called as a p orbital. Now N is equal to 3, that is nothing but you are having in that third shell, third orbit, that means M orbit. It having of subshells are 3 subshells are there. One is 0, 1, 2. 0 means s orbital, 1 means p orbital, 0 means s orbital, 1 means p orbital, 2 means d orbital. Similar manner, in the fourth orbit, 4 subshells are there. This is s orbital, it is p orbital, it is d orbital, it is nothing but f orbital. The maximum orbitals are only 4. Those are s, p, d, f. Sharp, principal, diffuse, fundamental. Why the s, p, d, f is put forth? Sharp, principal, diffuse, fundamental. By means of spectroscopic studies, it is derived the names s, p, d, f only. See friends, in this, according to my concept, I will generally explain this one. This is a pillar. You are constructing the house. This is a main pillar. Nucleus is pillar. Above the pillar, we are constructed one floor, that is called the first orbit. Second floor, second orbit. Third floor, third orbit. Fourth floor, fourth orbit. The permission is given by our GHMC. 4 floors are permitted. Okay. In that floors, the rooms also the permitted by the GHMC. The first floor you have to construct only one room. The room is called as a S room. Only one room. Right, friends? Now coming to the, after the one room, you want the so many number of rooms. You have to construct the second floor. In that second floor, the only the permission is 2 rooms are permitted. One is called as a S room, another is called as a P room. One is called as a S room, L is equal to 0, another is called as a P room. You are constructed so many, means you are constructed third floor. In the third floor, GHMC is permitted only 3 rooms. that is SPD. That is called as this one. Last maximum floor, that is fourth floor. The JMCFC is given a fourth floor only permission. In that, you have to construct the 4 rooms. This is the reverse order of household construction. Okay. This is the process we are using of in the azimuthal quantum number. So azimuthal quantum number gives what is how many number of subshells are present in the main shell. Main shells are KLMN shells. In that main shells, how many subshells are there? First orbit is only 1 subshell. Second orbit 2 subshells. Third orbit 3 subshells. Fourth orbit 4 subshells are there. These named as, if L is equal to 0, the name is called as a S orbit. If L is equal to 1 is called as a P orbit. If L is equal to 2 is called as a D orbit. If L is equal to F is called as a, that is L is equal to 3 is called as a F orbit. And also here also he explained in the azimuthal quantum number. The first orbit can accommodate 2 electrons. That 2 electrons are present in the S orbital. So S orbital can accommodate maximum number of electrons can accommodate only 2 electrons. And the second orbit, how many maximum is 8 is there. Already in the second orbit, 2 rooms are there. One belongs to the S room, another belongs to the P room. S can accommodate maximum is 2 electrons. So 2 minus 8 means 6 more electrons. 6 electrons can accommodate by the P orbital. This is also very important. S orbital can accommodate 2 electrons maximum. P orbital can accommodate 6 electrons. D orbital can accommodate maximum 10 electrons. F orbital can accommodate maximum 14 electrons. Please friends, this also you can remember in this azimuthal quantum number. So azimuthal quantum number is a big quantum number. It is explained so many things. That means in the main shells, subshells are present. In the subshells, how many number of electrons can accommodate? So S orbital can accommodate maximum 2 electrons only. P orbital can accommodate maximum 6 electrons only. Please remember this is useful for the writing of the electronic configuration. 1s2, 2s2, 2p6. You are writing 1s2. S2 means 2 electron maximum. 2s2, second orbit in the S room. First they are entering. That means their maximum is 2 electrons. Then it will go to the P room. That can also accommodate only 6 electrons. After 2p6, 3s2, 3p6, 4s2, 3d10, 3d10. D orbital can accommodate 10 electrons. Like that, it will azimuthal quantum number is explained. Subshells and subshell can accommodate maximum electrons. And also, what is the shape of the subshells? S orbital is spherical. It is a spherical shape. S orbital, spherical. P orbital, dumbbell shape, dumbbell. D orbital is, P orbital is dumbbell shape. And D orbital is double dumbbell. It is double dumbbell. And F orbital, complicated in structure. Why? Because it is 3-dimensional structure. It is a complicated. So the shape also explained by the azimuthal quantum number. So it is the significance. This is the first. This is second. The significance is size shape of the orbitals, shape of the subshells. So azimuthal quantum number is explained. The significance is shapes only. That means S orbital is spherical, P orbital is dumbbell, D orbital is double dumbbell, and F orbital is complicated. Now we'll go to the third quantum number, that is a magnetic quantum number. We'll see the magnetic quantum number. I will finish within 2 minutes, 2-3 minutes. Third is magnetic quantum number. This is represented a letter as ML. This is represented letter ML. That means this depend on the azimuthal quantum number. ML values are minus L2 plus L including 0. Including 0. This is a values will be present, which are present in this one. That means if n is equal to 1, means L is equal to 0. M is equal to what? It is also 0. It is nothing but S orbital. S orbital, how many number of partitions are present in that? It is called as the orientation. The magnetic quantum number gives the number of orientation. Orientation means in our language, I am saying that the first floor we are constructed. In the first floor, we are permitted only one single room. That is called as the S room. In that single room, you can partition will be takes place means the GHMC is not approved. It is not partitioned. That means you don't want the kitchen, don't want the bedroom, don't want the hall, only single room only. The single room it is called as a m is equal to 0. 0 means no value. That is not a meaning. It is a single room only. So the orientation is number of orientation of s orbital is only one orientation. That is called as a m is equal to 0. Second, coming to the n is equal to 2. It is having of L is equal to 0. One S room is there. It is the orientation is 1. And L is equal to 1 also there. N is equal to 2 means. L is equal to 1 means M is equal to 1. What are the M values, sir? L is equal to 1 means you have to apply minus L2 plus L means minus 1, 0 plus 1. How many number of orientations are there? 3 orientations according to magnetic quantum hour. According to our version, 3 partitions: kitchen, bedroom, hall. 3 portions are there in one P room. S orbital only single room. P room is consisting of 3 partitions are there. That means minus 1 means it is a orientation of px direction. 0 means m is equal to 0 means y direction electrons are there. P plus 1 is the pz direction. That means 3 rooms names are px, py, pz. Okay, like that. N is equal to 3 means there is a L is equal to 0, L is equal to 1, and L is equal to 2 means M values are minus 2, minus 1, 0, plus 1, plus 2. How many number of rooms are present in the D? 5 rooms. 5 subshells. These are the subshell. Subshells are 5 are there. So that's why if you see the S room means you can write as single room. If you write as a P room means you can write as a P room. These are the 3 partitions. D room you can write as 5 partitions. 1, 2, 3, 4. These are the 5 partitions. Please remember, this is you are representing the electronic configuration. Like this, your representation will be takes place. These are 5 rooms are there. See friends, in this each room, even though it is a partition, this it can accommodate 2 electrons. That means S orbital can accommodate 2 electrons. P orbital can accommodate 6 electrons. But 6 electrons must partition 2, 2, 2 only. Total 6 electrons. D orbital can accommodate 10 electrons. There must be 2, 2, 2, 2, 2, so total 5 into 2, 10 electrons. Like that, M is equal, suppose L is equal to 3. M values are minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. How many are there? 7 rooms are there. F orbital is having of 7 rooms. 1, 2, 3, 4, 5, 6, C. These are the 7 rooms which are present in the F. That means 2, 2, it can accommodate 14 electrons. Okay, friends. So 14 electrons. That means each subshells it holds only 2 electron maximum. This is explained by the magnetic quantum number. Magnetic quantum number is explained by the Landé. Of course, the M values are minus L2 plus L. This is proposed by the Landé. Okay, so it is values are M values means the number of orientations px, py, pz, and d orbital are in the 5 orientations dxy, dyz, dzx, dx square y square, dz square. 5 rooms names also clearly mentioned. xy, dxy. That means these first 2 electrons are located on x and y axis. yz, zx, x square, y square, z square. The location will be taken place in that. I will explain with the shapes of the orbital. That's we are getting of this particular clarification. Next, M is having of complicated structure, but they are having of 7 orientations are there. These 7 orientations are represent in this magnetic quantum number. Okay. So friends, this is about the magnetic quantum number. The last quantum number is you are having of spin quantum number. The last is the inner our quantum numbers. Spin quantum number, very easy number. That is a spin means what is how the electron will be spins. The electron is rotating in clockwise direction, anti-clockwise direction. If the electron is rotating clockwise direction is called as you are having of the upward arrow mark. If the electron is rotating in anti-clockwise direction is called as downward arrow mark. So the electron, it is a Gauss-Smith is this is proposed. The represented as letter MS. The MS values are only plus of and minus of. The 2 values are there. That means this is the atom. The electron is present like this. The electron is rotating. That means this is the electron is rotated in clockwise direction. So it can represent as upward arrow mark. This ms values are plus of. Clockwise direction, the electron is rotated, ms value is plus of. If the electron is like this, same here, this is rotating in anti-clockwise direction. This is a rotation will be takes place anti-clockwise direction. It will be downward arrow mark. It is ms value is minus of. So friends, in the subshells we say s orbital only one room, p orbital 3 rooms, d orbital 5 rooms, f orbitals 7 rooms. Okay. So the electron, first electron must be spin in clockwise direction. Another electron anti-clockwise direction. Clockwise direction, anti-clockwise direction. Okay. This is about the picture we are having of that one. This is about the quantum numbers. Tomorrow we can explain the remaining part. Why? Because this is only atomic structure 1. Atomic structure is 2 is there. And also I will try to complete in the block 4. That is any one chapter. Why? Because in this gaseous state is there. That's also very laborious topic. That also you can not covered it. And the remaining is periodic table is there. Chemical bond is there. Like that you can take the next class. Okay, bye. Too much time is over.